Well, that's good. You've all seen all of my slides already. So yeah, we're done. We're done. So what I want to talk about is Ligato, which is, as we said, a platform for developing cloud-native microservices that are focused on basically VNFs, so network forwarding containers. So I guess Ray was saying earlier, this is one of the challenges we've got, is that so far most virtual network functions have been delivered as virtual machines, and it's been fairly straightforward that we just take appliances that are generally they run on x86. You just take that code, put it in a virtual machine, and away you go. But we're trying to move this to containers, and I'll come on to why we're doing that. So really, part of this is just mirroring what's happening in the rest of the world. So this is interesting. I can't actually see my screen while I present. So I have no idea what's coming next. Because not only am I pretending to be Jan, but I've stolen his deck. So your guess is as good as mine as to what follows this. So as the whole app world has been moving away from this very monolithic, physical servers, waterfall development, the rest of it. And the thing is, as I was saying, we haven't really mirrored that enough in the network. So what we're trying to do here is mirror what's been going on in the rest of the world, which is out there in the conference with thousands of people, with what we here in the network with all 50 of us are doing. So if you look at how this happens in applications, your apps get broken up in a way that we never did in the past. So in the good old days, you'd literally have I don't know who here remembers the days of 3-tier client server, and it was the big buzz, wasn't it, back in the 90s? And you would have your app tier and your database tier, and those would tend to be fairly monolithic. Each one was delivered on a server, and you had a network connection between them. And this is probably where I should start talking about pets and cattle, because we all love this in containers, don't we? Everything was quite bespoke. So you'd have a server on which you deployed a particular app that would then talk to a database instance. And it was managed very sort of monolithically, but also small numbers of things. And what we're trying to go to is a world where both the servers and the containers that run on them are cattle now, not pets. We have thousands of servers, each one running hundreds of applications, different pods coming up, going down. So as we do that, also, the problem becomes that we are, because we're disaggregating the apps into smaller and smaller pieces, naturally, as a result, you're going to have more and more traffic flowing between those components. So the network itself, the danger is that becomes your bottleneck. Because what you want to do is, instead of saying, well, we're going to build a topology, like a network topology for a specific application, you're saying, right, we're just going to build this giant leaf spine architecture. We're going to stick all our servers on the end of it. And then our apps are going to have to run over that, and we'll use overlays to do that. So the performance of the networking is going to be absolutely critical. So as I said, up to now, the container world's mostly been focused on sort of more generic applications, not networking stuff. And so, certain range of problems have been addressed, but it still leaves us with a bunch of issues as network people. So, how do we actually do networks and network security over this? I think Chris, you talked about, the whole service mesh thing. Service mesh, great. We want to fit in with that, but that's very much focused on the sort of what we as networking geeks would call sort of layer 4 and above stuff. It's all really about TCP, HTTP. Cloud network functions, we're going to be talking layer 2, layer 3. We're going to be wanting to bridge things together, like stitched, almost like pseudo wires from the WAN, but going through the data center. So we're just chaining these things together at layer 2. And that's very different. And of course, we want to be able to deploy this, not only in our own data centers, but across clouds, because it's the cloud native thing again. We want to be able to put this in Amazon or Microsoft or whatever. And the other problem we have, and I guess Ray talked about this earlier, didn't you? The sort of the bottlenecks of networking and how do we get around that? And we know that we need to get to user space networking. We talked about VPP briefly. That's been presented multiple times today. So everything I'm doing here is really stuff that sits on top of VPP to orchestrate it. So it's high performance, user space networking. But of course, storage has got to come into this as well, because ultimately, at the end of the day, anything you're storing it because somebody wants to access it. You're not storing it for fun. And if they're going to access it, then you're going to have to get to it over the network. So in container networking today, we have always great orchestration and lifecycle management, but the real problem, I guess, comes down to how is the connectivity done? It's all done as an overlay that has NAT in it. And then with the service mesh, we then tend to put web proxies on top of that. And the NAT really isn't something we want to do for NFV use cases. It's very handy because you can have a Kubernetes cluster IP that then gets deployed effectively to as many pods as needed. But NAT is not something we want here. And I see Ola sitting there in the front row. I mean, every time I say nat, Ola throws up a little bit in his mouth. Why did that move on? This is really interesting. It must be like as I move or something, it steps on. Okay. We already had the name check for 12-factor app design, but we're trying to be very cloud native here. But at the same time, and I know Ray said, sort of performance, you could choose it or choose not to have it. Well, here we're kind of laser focused on performance. And I think Jerome may talk about some of the performance numbers later. You're going to, the performance we get out of VPP is quite extraordinary. Almost as good as the performance we get out of this projector. Maybe it's just telling me to speed up. Yeah, let's just do that. So you can always look at the slides afterwards. And I hate talking about what's on my slides. I did want to talk about that one, though. This is remarkable. What's triggering it? Just timers in the deck. HTTP, but why did Jan do that to me? Maybe because he talks faster than me. So we're putting together, you see, Kubernetes, Contiv, Ligato, and VPP, Fido. I was sure there were no timers in here. Maybe it's a Mac PC thing. Yeah, exactly. No, this is more fun. You can keep looking at it, and every time it moves. Actually, why don't I do that? Oh, no, of course. I can't do anything, can I? Because I can't actually see what I'm doing. Oh, this is great. This is awesome. Let's just carry on. Actually, yeah, that works, doesn't it? Yeah. Sorry. Ah. Talk amongst yourselves quietly. There you go. Yeah. Just leave it, exactly. Yeah, so bring these different things together. So Kubernetes for container orchestration, Contiv, so Contiv is our container networking solution. The next iteration of it will be using VPP, and we'll come on to that. Ligato which is the main subject for today, is really all about how do we do cloud-native network functions. So you could call them CNFs instead of VNFs, if you like. And then underlying it is the data plane, VPP, Fido. So how does it come together? Well, you can think about sort of the logical layering, but then also, how does that get deployed? So we have this component, the SFC controller we'll come on to. The other component in Ligato is the VPP agent. So the SFC controller basically takes input either from YAML files or REST APIs. That's a centralized component that you use to define what you want your VNF deployment to look like. Then the individual network functions run this VPP agent, which programs VPP. So all of this, what we've tried to do is make it as cloud native as possible. So all written in Go. We're using etcd as the distribution mechanism between the two. So if you come to look at how do we build it, well, we use etcd as the distributed data store between the components, and then we're using Kafka as a message bus. The layering itself, for example, in the agent, we have an implementation of a VPP API written in Go, so Go VPP. And then on top of that, we built this infrastructure. And of course, all of this stuff is open sourced, and I'll show you the GitHub stuff later. So I guess 2 or 3 different aspects to talk about. Firstly, Contiv VPP. So in terms of Contiv VPP, well, what is this? Well, we're saying, well, forget the containerized network functions for a moment. But think about, OK, so you're deploying just generic container applications, and you want higher performance for your networking. How are you going to do this? Well, we can take the same stuff that we built for containerized network functions and say, well, we can build a vSwitch, which effectively is a containerized network function, and just use it as a generic vSwitch to connect applications together. So the Contiv VPP infrastructure does everything you'd expect of a CNI in Kubernetes. So allocates addresses, programs the infrastructure. I mean, initially today, we're using absolutely standard container networking stuff in terms of its VXLAN over IPv4. We effectively create a VNI that interconnects all of our servers, and then we route over that. And then as we come to containerized network functions, we're going to create more VNIs and switch over those. And of course, we implement Kubernetes network policies. In terms of the network services themselves, so the cluster IPs, initially what we did for our first demo was we let all that stuff run through the kernel, and we just handled the data forwarding after that. We've now implemented the NAT, effectively the ACL-based NAT in VPP, which enables us to host the cluster addresses through VPP. Though, of course, that, as I said, with service meshes, that all this stuff kind of gets interesting because there's proxies there anyway. So the next thing we'll come on to is how do we then tie things like Istio and Envoy into this. And in terms of performance, we're an order of magnitude ahead of what you get from anything else from the likes of Calico. And that really comes down to the fact that we're using VPP, staying in user space, avoiding the kernel. So entirely from user space. So how do we, the question now I guess is, how do we get past the kernel? So there's a couple of different approaches. We have the MEMIF, which is what we use for containerized network functions. So this is just a memory interface, typically between two different VPP instances, one running in the vSwitch and one running in the container. But in recognizing that most of what people are running as applications in Kubernetes is TCP-based and HTTP-based, what we've actually implemented is a TCP stack inside VPP. And so what happens here is if the two pods are running on the same server, it just sets up a FIFO between them. If they're running on different servers, then it's an implementation of TCP. But that's all happening in user space in VPP. And the work we're now doing is to hook in with things like Envoy, so they can hook straight into our stack instead of hooking into the kernel stack. There's two ways to do that. One is we can LD preload it, and we use a CRI to enable that. But the better approach is that we have our own, effectively our own socket library. So you were talking about sockets earlier, weren't you? So yeah, we have our own socket library that you can hook into, and that will give you the best performance for this. But equally, if you can still use the kernel stack, of course, because we can use VTs and taps. But if you use the kernel stack, of course, an order of magnitude performance difference. So as much as possible, try and move stuff onto the stack. So the second thing to talk about is how do we actually do the cloud-native network functions? So we want to take advantage of containers to get performance. There is a challenge there in that typically then what we want to do is to break applications up into smaller components rather than deliver them as these big monolithic apps. We have some use cases out there where we're deploying sort of broadband infrastructure using this kind of approach. It looks very good in terms of performance. And what it means ultimately is that your network functions then become part of your service topology. And so the network function is just another service as far as we're concerned. The question then, of course, is what does policy mean for that? Because the policy that you'd apply at layer 4 or layer 7 is probably different to the policy you'd apply at layer 2, layer 3. But we really want to get the benefit of this whole cloud-native world in terms of velocity of implementing stuff. So Ligato, as I mentioned earlier, is the mechanism we use for this, written in Go, and we have this SFC controller that does all sort of management, and it pushes stuff down to these VPP agents that run on the hosts. And so what it changes compared to the last picture, you can see the sort of whole Kubernetes space is still there, but then we have this Ligato stuff effectively sort of out on the side as another means of getting through to VPP agents. And so just as we can program the vSwitch VPP agent through config VPP, we can now have VPP agents that sit in the VNFs. And then, as I mentioned, typically what you would have is you'd have a MEMIF effectively between two VPP instances, one running in the vSwitch and one running in an application pod. Only it's a different kind of application now. Of course, the fact is that typically what you're doing here is you're deploying network functions in chains, or that's the goal everyone wants to get to. So it's not just, hey, here's a firewall, that's it. It's let's have a chain of things, firewall, web inspection, filtering type stuff, and chain them together. So you have a router at ingress, a router at egress, and then chain the network functions together. And so, as I mentioned, the way we stitch them together is effectively just using separate VXLAN instances, VNIs, for each sort of hop in the chain. Longer term, we're looking at other approaches, and I know somebody's speaking later today about SRv6. That's another future approach. But what we need to do is we need to have this kind of logical representation of how's that chain going to be built. And then we need to have a rendering function, which is part of the SFC controller, that says, OK, let's figure out how to deploy that onto the network. But as I said again, you know, the servers are cattle and the containers are cattle, so we don't want to, as much as possible, we don't want to have constraints in terms of which servers we put stuff on. Modulo, the issue Ray mentioned earlier about you might have certain accelerators on certain servers that you want to leverage. Plus also in some cases you might say, well really, these things are very tightly coupled, it's a chain for one customer. Ideally we'd like to just stick them all on one server, because actually, you know, bouncing around the network is going to be a performance issue, however fast your network is. In an ideal world, you stick it all on one server, you're good to go. So the way we can chain them together is we can chain locally on, you know, via one local vSwitch, or we can even have pods just go straight pod to pod without going through the vSwitch. And of course, in that case, you don't have to assign any networking resource. There's no VNIs being assigned, etc. But then where they are on different servers, we'll set up a tunnel between them. And so the sort of logical view of this is, you know, we tend to think in terms of having some kind of management overlay cloud network, as we'd call it, that basically stitches everything together. And, you know, here's where our etcd instance is, our Kafka, et cetera, is running. But then we're going to have one or more data plane networks, which are going to be effectively connecting to the routers on ingress and egress. What you probably find, I mean, we have done some work enabling us to use basically one NIC to do both these functions, but I'm guessing in most cases people might have like a gigi LAN on motherboard NIC, and that's the one that they're hooking into the kind of control plane. And then you would have these, you know, multi-port 10, 25, 40, et cetera, gigabit NICs that you'll be using for the forwarding plane. And I believe there's a vendor of such devices sitting in the front row. And so then that's how it, you know, how it ends up getting rendered is we have the NICs, the high-performance NICs hooking into the data plane. DPDK is the layer between the NIC and us, so that we're running in polling mode rather than interrupt mode. And then we instantiate multiple VRFs in our vSwitch, which can either connect through those NICs or through the LAN motherboard, et cetera. And as I mentioned, typically what we'll have is one VRF for our sort of generic Kubernetes apps, or there could be several, but then we'll actually do virtual switch instances for data plane stuff. The final thing to talk about, I guess, is we talked about controlling user place separation. I think, Charles, you mentioned that in context of OpenFlow. And I know it's a big sort of thing that people talk about in the world of 5G, isn't it? They're all talking about this cup stuff. So, and really just to say that's how this ends up, is that effectively, you know, you'd end up probably with a cluster of servers that are running your control plane for this. And so that's where Kubernetes, etcd, the SFC controller, et cetera, is going to be running. But then in the data plane, you'll have servers running these VPP instances. And so you have your sort of master controller that does all that control plane, and then effectively that would be that cloud network really sitting between here and here. And then you have your data plane networks hooking into the network. So, where can you get it all? Where else but GitHub? My thanks to GitHub, because they provided me a very nice coffee this morning, which is probably why I'm managing to get through this. And so just look for Ligato on GitHub. It's all up there. In terms of components, we have the CN infra. I'm sure you can't see it because the font's way too small. But the CN infra is just kind of the base infrastructure. And then on top of that, we layer things like the VPP agent. So the CN infra is just a it's really just a platform for building any kind of cloud-native function. And in that sense, it doesn't have to be VPP. So again, I mentioned the MEMIFs, and typically a MEMIF would go between a VPP instance running in a pod and a VPP instance running in a vSwitch. But of course, you might not always be using VPP. There could be other forwarders using, I mean, they could be using some of the stuff from Intel. So why not have a more generic infra that we can then plug that stuff into? And the way it works is very much, you know, everything's a plugin. That's tended to be our approach in this and in the VPP agent, which I'll show next, is that everything's just a plugin. So I guess the ask for today is get up there, take a look at it, and start writing plugins. And yeah, so the VPP agent, again, all about plugins, hooks into the CN infra, and then we build things like policy, et cetera, into that. And as I mentioned, the Go VPP work, which lets us hook into VPP itself at the bottom layer. And again, that's out there and can be consumed separately from Ligato. Oh yeah, we're done. Fantastic. Any questions? That's all right. We can take questions. It's always good.
You're using Kubernetes and you're not using that, so you can actually that's very simple.
Sorry?
Hello? Oh,
Yes.
so you're using Kubernetes and you're not using that. I think that means you're using DNS, is that right?
Sorry, using?
DNS.
Well, kubedns gets used, yeah. For
Okay.
backups, yeah.
Yeah, thank you.
Any other questions?
You mentioned VPP on the Envoy. Does that still use Ligato, and is Contiv involved in that stack, or is that an alternative implementation?
Well, we're using it as part of the Contiv VPP thing, but again, it's separate work. So you could presumably hook. I can't see why you would need Contiv to hook that in.
Yeah, that's what I was.
That's just the VPP stack in. Sorry, the user stack in VPP, the TCP stack in VPP, and you could just hook that into Envoy without this stuff. Yeah.
Yeah, cool.
I mean, that was just that we recognise that Envoy. I don't know what people see out there, but Envoy just seems to be winning in this space. So always go with what's winning.
Sorry, I missed if you had like a background slide, but are you you're not a service provider or what?
Oh, I'm from Cisco. So, and I guess we're just throwing this out here as open source to see who catches it. No, because we're still coding it, I guess. We were demoing this stuff at KubeCon in Austin just before Christmas. But certainly, we're planning to use it ourselves.
Would you mind repeating the question?
Oh, all right. Oh, yeah. He was asking if there were any users of this technology yet. And I was saying, we were just demoing it at KubeCon before Christmas. And yes, we plan to use it ourselves, but also it's out there, it's open source. So if any of you guys want to pick it up, then please do.
Any other questions? Okay, so we've got thank you so much.
All right.